Welcome back to Edpuzzle with Rachel. Today we're going to be talking about exponential growth and percentages. We're going to save decay for next time. So let's get started. Consider this warm-up. You see a pair of shoes online that you want. They cost $150. If there is a 10% sales tax on the shoes, how much will the total cost be? Just take a guess. If you said C, 165, you're correct. I know the other choices don't look so great, but we're going to talk about how to actually calculate this a little bit later. Let's talk about percentages for a second. In the show Shark Tank, someone walks into this scary room with a business idea or a product. If you were going to start a business, what do you think you would make your business be? Very cool. So here's Lori Grenier. She has a ton of money and she's looking to invest in a business. She offers $200,000 for a 5% stake. What could that mean, 5% stake? Well, 5% doesn't really mean anything unless you know what you're taking 5% of. So, would you rather have a 5% stake in Google or Dave's Deli across the street? There's really no wrong answer here, but if you're looking to make more money, Google's going to be your best bet because 5% of Google is going to be a lot more than 5% of Dave's. If we're going to do math with percents, we need to know how to convert them into decimals, and maybe the other way around. 50%. How do we change 50% into a decimal? Well, here's my little trick. I like to use dupe. It stands for decimal over percent. It just reminds you where to move your decimal point and how many times. 50%, well, I'm starting as a percent, so I know my little decimal point is going to be there if I'm using dupe. I don't actually see a decimal point in 50%, but I know it's secretly to the front or to the right of the number. To go from a percent to a decimal, I have to move my decimal point 2 places to the left. I do the same thing with my 50%. My new decimal point is now to the left of the number, and I don't need the old decimal point or the percent sign. And I can write this as either 0.5, 0.50, 0.5, 0.50. Those all mean the same exact thing. What would 60% be as a decimal? Well, here's how you do that. Move your decimal point 2 places to the left, you get 0.6, or any of these other variations. What do you think 2% would be as a decimal? This one's a little bit weirder. I have my decimal point there. I go to move it to the left, and even though I ran out of numbers, I keep going. I move my decimal point there, I cross out what I don't need, and inside of that empty loop, I'm going to put a 0. So when I write my answer, I just need to make sure that I copy it correctly. You could throw a 0 in front if you want. 0.4%. I know it looks like a decimal, but because there's a percent sign, I'm starting as a percent. So I need to move that decimal point 2 places to the left. I cross out my old decimal point, my percent sign, and I fill in the empty loop. I need to be really careful that when I'm writing my answer, I keep track of the number of zeros that I have. All right, let's talk about changing decimals to percents. The number 1, I know it doesn't look like a decimal, but just like with the percents, I can put in my own. So now I'm going in the other direction. There's no percent sign in front, so it's a decimal. What direction do I move my decimal point in to go from a decimal to a percent? Well, I'm going to go to the right. 2 places. I fill in my zeros, get rid of my old decimal point, and put a percent sign. So the number 1 is 100%. The next one's a little more straightforward. I have a decimal point. I know I need to move it 2 places to the right. What do you think 0.25 is going to be as a percent? Well, that's going to be 25%. What about 0.3? What's that going to be as a percent? I move my decimal point 2 places to the right, cross out the 0 and the decimal point. Now I'm going to get 30%. What about 0.03 as a percent? I move my decimal point 2 places to the right, and there's actually a lot here I don't need. I don't need my old decimal point, I don't need that first 0, and I don't need that second 0. I'm just left with the number 3. 3%. Now I can do some actual math. 10% of 150. This is great for calculating sales tax. If you want to tip someone, although you should probably tip closer to 20%, especially in a pandemic. So if I want to put this in my calculator, I don't have a percent button. I need to change this percent to a decimal. You can use dupe. In this case, I'm starting as a percent. I need to put a decimal point there. What do you think 10% is as a decimal? Well, if I move my decimal point 2 places to the left, I get 0.10. In math, the word of means to multiply. So I do 0.10 times, and 150 is just itself. So what is 0.10 times 150? That's going to get you 15. So 10% of 150 is 15. Back to our warm-up. Here's what I could do to calculate this. I know I'm starting at 150, and there's a 10% sales tax. So I need to take the original cost of the shoes, 150, and if I'm including tax, should I be adding something or subtracting something? Adding. Tax is adding. So I'm going to add the tax. I know we did this on the last slide, but here's how you do it again. I need to calculate the tax. 10% of 150, well, that's 0.10 times 150, that was 15. So I would do 150 plus 15. I have the original plus my tax. Combine those, you get 165. Okay. Let's say you get $150 to put in the bank. Very similar to the last problem, you get to add 10% interest every year. That's a pretty high percentage, but let's pretend that's realistic for this question. To calculate how much money you're going to have every year, you're going to want to do something like this. You want to take 10% of what you were given, which is 150. 10% of 150, we already know that that's going to be 15. So I take my original, 150, I add my interest, and I get my new total, 165. So that's after the first year, I get $165. That's awesome. I'm going to go ahead and calculate how much I get the second year. How much am I starting with in year 2? I'm starting with my new total, which is 165. I don't go back down to 150. I'm going to calculate 10% of 165. What is 10% of 165? Well, here's how I can do that. I know that 10% is 0.10. I'm going to multiply it by 165, and I get 16.5. So that's going to be my interest that I add on to 165. How much do I get at the end of my second year? Well, 165 plus 16.5, I get $181.50. I'm going to put the 0 there just so it looks more like money. So if I'm going to keep my money in the bank for more than 2 years, this process is going to get really exhausting. When you invest money in the bank, you could leave it there for like 50 or 60 years, however long you're going to be alive, you're probably going to have money in the bank as soon as you open an account. So what the banks do to calculate how much money you get is they use an exponential growth formula. This is a life hack, so you don't have to keep doing this year 1, year 2, year 3, and so on. I'm going to fill in the numbers from the last example into this formula. What was the final amount that I ended up with? Well, that was 181.5 or 0.50. How much money did I start with? I was given 150 at the very beginning. Now the next part of the formula is built in for you, and this one here means that when I'm adding money or I'm adding interest to my original amount, I don't want to just end up with $15. I want to include the original and then add on top of it, and that one does that for you. Don't worry too much about that. I have a plus sign here because interest means that you're earning money, you're going to get money. The next part is where people get a little confused. You're going to put your interest rate. That's going to be the percent, but you want to make sure you turn it into a decimal. What I don't want to do is put 10% right there because that's not good for calculators. So I want to make sure that I turn my 10% into my 0.10 so I can actually calculate. And then the exponent here is going to be your time. A lot of the formulas have time represented as t, but in this case, we know that to get 181.5, we calculated it for exactly 2 years. And that's how you use the formula. You have your final amount, your starting amount, your rate as a decimal, and then the time. And that's all you need. Let's try some examples. Let's say I wanted to calculate a 6% increase. In order to use my formula, I have to change 6% into a decimal. What is 6% as a decimal? Here's how I do that. Imaginary decimal point there. I go 2 places to the left, fill in my 0, get rid of what I don't need, and I have 0.06. Let's try this again on the next example. What would 0.5% be as a decimal? Same deal. I have my decimal point. I go 2 places to the left, fill in any loops with zeros, get rid of what I don't need, and just be really careful that you copy down the correct number of zeros. This formula might do something to simplify the way it looks. You don't have to have a 1 plus. You can just add 1 and 0.06. So this could look like, I'm just going to recopy those. If I add 1 plus 0.06, I just get 1.06. And then copy my exponent. If I was to simplify this next one, what would that look like? I copy everything down. I add 1 plus 0.005, and I get 1.005. These are the same thing. One just has the addition already done, and one is before the addition is done. Let's do an example. Rhonda deposited $3,000 into an account. The interest was 4.2%. Write an equation that can be used to find B, her balance after T years. I only read what I really needed. How much did I start with? 3,000. And what is my interest rate as a decimal? Here's how you do that one. I'm going to take 4.2%. I can use dupe. If I'm starting as a percent, I go 2 places to the left, fill in my empty loop, get rid of my decimal point, and I have 0.042 in that spot. Now, I ran out of numbers to use, but I did get some letters. What letter from the problem do you think goes in the spot for time? If you said T, you are correct. And I only have one more letter here, which would be my final account balance, and that's B. I'm going to have you try this one on your own. I'll read it out. Marilyn collects old dolls. She purchases a doll for $450. Research shows that this doll's value will increase by 2.5% each year. Write an equation that determines the value V of the doll T years after purchase. Here's what this one will look like. I am starting with $450. I need to change 2.5 into a decimal, so I go 2 places to the left, which is 0.025. They told me to use T for time and V for the final value. Okay, another type of question you would see on the Regents is asking about what happened? What does this number really mean? So we already know that that has to do with a percent increase, percent decrease, something with a percent of change. So if I look at my choices, I have to decide, is it going up? Is it going down? And by what percent? So I'm going to show you a couple of tricks that you can use to get these types of problems correct every time. So just by looking at the choices, I know I'm going to be dealing with this number here that's in my function. So I'm going to take that number, recopy it, 1.02, so I can work with it. All of my choices have percent signs, and this number does not. So I know I need to convert it. I'm starting as a decimal, and I need to go to a percent, and I know that means 2 places to the right. What would 1.02 be as a percent? Well, here's how you do that. 2 places to the right. There's your decimal point. Cross out your old one. And I have 102%. If they're asking you what happened to get to 102% decay or growth, here's what you do. You always start at 100%. That's your base. You're always going to be working from 100%, and then whatever decimal you get from the problem, that's going to be your change. So to get from 100 to 102, did you increase or decrease? You increased. You went up. So I need to get rid of any choice that says I went down. Which choices can I get rid of? Well, that would be choice 1 and choice 3 because they say decay. Now, choice 2 and 4 look almost identical, but one says a decimal percent growth and one said 2% growth. Here's what you do. You take whatever percent you got from the problem and you can subtract 100 if it's over 100. Or this is like mental math. How do you get from 100 to 102? It's 2%. It's like you got 2 bonus points on a test. But you could also do the subtraction. Take 102, subtract your 100%, and you get your 2% growth. This one looks way worse than it actually is. First of all, if I'm looking at my choices, the only things that are different are the plus sign versus the minus sign and the placement of that decimal point. I actually don't need to look at any of that. Let's look at our question here. It says that the population is growing. Do you think I need a plus sign or a minus sign? Definitely need a plus sign for growing. So I'm going to get rid of any choice that doesn't have a plus sign. And that would be choice 1 and choice 4. Gone. The only difference between choice 2 and choice 3 is the placement of that decimal point. It mentions 31, so I know I need to look at this. I'm going to recopy it, 3.1%. It's a percent. My choices have decimals. I'm going to convert it. To go from a percent to a decimal, I move my decimal point 2 places to the left. What is 3.1% as a decimal? Well, here's how you do that. Move my decimal point 2 places to the left, cross it out, cross out my percent sign, and I'm left with 0.031. If I throw that 0 in front, it's easy to see what's my correct answer. Well, that's going to be choice 3. Why don't you try this one on your own? It says the equation A equals 13,000 times 1.02 to the 7th is being used to calculate the amount of money in a savings account. What does 1.02 represent in this equation? So looking at the help box, I know I need to calculate what 1.02 would be as a percent. I'm starting as a decimal. I go 2 places to the right. So that's going to be 102%. Starting from 100, to get from 100 to 102, I know that I have a growth or an increase. So that gets rid of choices 1 and 3. To get from 100 to 102, you can show the subtraction, and it changes by 2%. This here is just to trick you. Good work today. We've talked about exponential growth. Next time, we are going to mention decay. What do you think decay means? Yeah, that means to decrease and to go down. So good work today, guys, and I'll